So now we're going to recap two more exponent rules and how to connect them with negative exponents. So let's first start out with the power rule. So the power rule is, example, is the following. Let's just say I gave you this. If I were to ask you to use a power rule, how can you simplify this? Well, keep in mind this 2 tells you that there's actually 2 of these brackets. So in these brackets you have 2 to the power of 3, 2 to the power of 3, and when we multiply things with the same bases, you add the exponents, meaning you got 3 and 3, which gives you 6. However, I want to kind of avoid this step. So if you look at here, the power rule says that if there are powers of powers, all you have to do is multiply to get the 6. So 3 times 2 will give you 6. So if I were to generalize this on the right-hand side, if I have b, m, and then I have n, all you have to do is multiply the exponents together. If we open this up to a more complicated bracket, instead of having a simple base, let's just say I open up to 2x squared y to the power of 2, for example. Okay, what happens? Well, this is the same thing as, just going to show you all the minor steps. What we have 2 of these brackets, and all we have to do is now multiply things. So you have 2 times 2, which is 4. Now the x's are doubled, the exponents are doubled, and keep in mind there are 1's on the y, so we have y2. However, I want to avoid this step. So how do we get from here to here? Now keep in mind this square here, or the 2, applies to every exponent inside the term. But miss, there's no exponent. Well, yes there is. To the power of 1, to the power of 1, and you multiply. So in other words, if I were to go from here to here, I end up getting 2 to the base of 2, base of x, and base of y. The bases don't change. The exponents change. This 1 is doubled, becomes a 2. The 2 doubles, becomes a 4. This 1 here becomes a 2. And then, the only thing you can simplify is this one here. 2 squared is the same thing as 4, and you end up getting that answer. So let's do an example where we have negative exponents. So we'll go back to the similar question. So I'll put here 3, and then I'm going to put a negative 2. So I'm going to ask you to simplify this, and your final answer should not have any negative exponents. So what do we do first? So there's a couple of ways you can do this. You can do brackets first, or you can do exponents. It really depends. So I'm just going to show you two ways. So let's just say you want to do bed mass. Miss, I want to deal with 2 cubed. So 2 cubed is the same thing as 8. And then we're pretty much done the question, meaning you can express this as this is the same thing as 8 to the power of negative 2. So you don't want to have brackets, you can just open up the brackets. There's a little 1 here, you can multiply it out if you wanted to. And this becomes, well, negative exponent means, well, 1 over the reciprocal, where the base is the exponent and the base, and then you end up getting 1 over 64. So that's one method. Another method is to use the power rule directly. So over here, I'm just going to multiply the exponents directly using the power rule. I get this. And then we can re-express this, because I did say I don't want to have negative exponents, so we can rewrite this out as 1 over, just keep in mind, negative exponent means you take 1 over the reciprocal of the base and the exponent, and if you work this out, you end up getting 1 over 64. So that's an example where negative exponents come into play. Now what happens if we increase the difficulty with numbers and variables, such as, let's just say 2x squared y, and let's just put a z, and let's put a negative 1. And let's put it all to the power of negative 2, for example. Okay, so we're going to go directly and use the power rule. So this negative 2 applies to every single exponent in this bracket. So in other words, you have 2x, y, and z. But now let's address the exponents. I'll use red. So this 1 here becomes, it's doubled, but it's negative doubled, because you're going to multiply it by negative 2. This 2 here is going to be doubled, we come with 4, but it's a negative 4 here. And over here, the y, well, the y has a 1, and this 1 is doubled, becomes a negative 2. Now the z over here, it's doubled, which is a 2, but a negative times a negative gives you a positive. So now the question is, I do not want to have negative exponents. So I'm going to underline the terms that have negative exponents, and we're going to have to deal with them. So let's deal with this one here. Well, we know that this is the same thing as 1 over 2 squared. This one here is the same thing as 1 over x4. So if you notice, the format is the same. 1 over y2. Now the z2, I'm just going to put it on the side. So I'm showing you all the micro steps. I know that some students can get the answer directly, and some students will eventually get the answer directly. You don't have to do this step eventually unless you want to. So over here, I'm going to simplify this. Now keep in mind, these four terms are being multiplied together. So when you multiply fractions, this actually is a fraction over 1. So let's look at the numerator. When you multiply the numerator, 1, 1, 1, it's just 1. So you have z squared in the numerator. Denominator, well, 2 squares is the same thing as 4. Now you have x4, you just put them together, and y squared, and you are done. So the last row is changing bases, and you actually have changed bases already in the previous examples. For example, you have 4, and you change it to the base of 2. But you might think, well, Miss, how is this a base? This is not even an exponent form. Well, yes, it is, because this is actually 4 to the power of 1. So you don't see it, but it's actually an exponent form already. So what I'm trying to say right now is, let's just say I had a 9. Well, if I ask you to change the base, you can change 9 into 3 to the power of 2. So when you change bases, you kind of have to know your multiplication skills when it comes to the base here. So what happens when I give you, for example, 8 to the power of 3? How are you going to change the bases? So the base is at 8. So you got to think of numbers that multiply, which are the same numbers, to give you 8. In other words, what we can do is, when I say change bases, that means this 8 is going to change into a different base. The exponent is still 3. It's just what's going to happen to the 8. Well, we know that 2 to the power of 3 will give you 8. And we can actually simplify this using the power law. Well, what happens when you have exponents next to each other? Well, this is the power law. You multiply them. So this becomes 2 to the power of 9. So in other words, from here to here, they are still base exponent, same format. However, the basis has changed. This 8 has become smaller to a 2. But what's interesting is the exponent has become bigger. So there is going to be a balance when you change bases. If the base goes down, then exponents go up, or the other way around. If the base goes higher, then the exponent's going to go down. But how is this related to negative exponents? Okay, so let's do, for example, 1 over 2. So this is a very simple fraction. It's not even an exponent form. Now this can be rewritten as 2 to the power of negative 1. I know that we're used to going from here to here, but sometimes, depending on the question itself, you may have to be able to revert a fraction, 1 over something, into a exponent form. Or we can change, for example, 1 over 10. It can be written as 10 to the power of negative 1. Another example is, well, 1 over 25. Well, there's many ways you can do 25, because 25 is an interesting number. Can you do 25 to the power of negative 1? Yes, you can. Or some students might think, well, 25 is the same thing as 5 to the power of 2. So in other words, you change the denominator into an exponent form directly. Now this whole format is not exponent form. This is actually a fraction form. Keep in mind, an exponent form has to look like this, up here. You have a base and exponents. But Miss, I have a base and exponent. Yes, you do, but this 1 is not part of your base and exponent. It has to be in this format. So how can you change this into a base exponent format, like this format? Well, keep in mind, this is the same thing as 5 to the power of negative 2. Remember, the negative means 1 over something, or the reciprocal of something. So this skill here is new to some students, a lot of students, and it will take some time to get used to, and you probably see this skill most likely in grade 12. So here we're going to actually go through 5 different examples, 3 here and 2 in the next slide. So let's look over the first one. So keep in mind, here we have a base, we have a negative exponent, and when we have a negative exponent, that means we're going to have to take the reciprocal of the base, 1 over 3 over 2. But I don't want to write down 1 over 3 over 2. I know that the reciprocal of 3 over 2 is 2 over 3, and then we have to the power of 3. Now, we're not done simplifying, because I want to actually deal with the brackets and exponents. In other words, I'm going to multiply everything. A couple of choices. You can multiply this 3 times, or you can use the power law, meaning this cubic applies to all the exponents in that bracket, meaning you still have the 2, you still have the 3, but this 1 is going to multiply by 3, and this 1 here also multiplies by 3, and then you can expand, which gives you 8 over 27. This next one over here is, well, you can do bedmass first, you can do the brackets first, but I know anything to the power of 0 is going to be 1. So I don't have to waste time. 3 minus 5. I know that the entire numerator is going to be a 1. And over here, what's 4 to the power of negative 2? So I'll put here 1 all over. This piece here will become, I'll put in brackets, becomes 1 over 4 squared. And I don't like having like vertically so much, so many fractions involved. So I'm going to put 1 divided by 1 over 4 squared. And that will give me 1 times, because when you divide a fraction, you take the reciprocal. This becomes 4 squared over 1. And then you just multiply things up and you end up getting 16. Now the next one here, this last one here, here's a common mistake. A lot of students will look at this and they'll think, oh, okay, I'm going to add the exponents right away. We'll give you this. Please don't do this, because the operation is not multiplication. If I change this to a multiplication, then you are fine. But if it's a plus, there is no such thing as an exponent law where you add something with same bases. Multiply, yes, but not add. So just be aware of that. Okay, so in this case, we're going to have to treat each individual question on its own. So 1, 2, and 3. So I'm going to have a massive fraction over here. This becomes 1 over 3, 5, plus 1 over 3 squared, and 1 over 3, 4. So basically, I'm working with exponents first. And last thing the second thing is I'm just going to expand. So this becomes 2, 4, 3, 1 over 9, all over 1 over 81. Put a bracket around here. Now you have a couple of choices. You can actually deal with the brackets first. And as I said, I don't like having fractions on top of each other. I don't like the verticalness of this. I'm just going to put it horizontally. You have a couple of choices, but Ms. Wong does not want to find a common denominator. I don't want to do that. So I'm just going to do a expansion. So I'm going to take this and distribute this twice. In other words, I'm going to, this should be divided. Actually divide first before I do that. So I did make a mistake here. So let's ignore this part here. So before I deal with this, I'm going to have to change this into 1 over 2, 4, 3 plus 1 over 9. But this is divided by 1 over 81. I'm going to have to multiply by 81. So what I'm going to do right now is I'm going to expand, because I don't want to deal with this part here. I don't want to think about LCD, lowest common denominator. I'm just going to multiply everything inside the bracket by 81. So 81 times 1 over 243 plus 81 times 1 over 9. And if I did this, this will give me 1 over 3 plus 9, which gives me 9 and a third. Now, if you want to actually do this first, you have to find a common denominator and then multiply 81. It doesn't really matter. You eventually get 9 and 1/3. So in the last examples, we're going to deal with variables and numbers. So the first example up here, we're going to look at there's a couple of choices. You can actually deal with the negative exponents first or deal with it at the end. So I'm going to deal with it at the end. So I'm going to deal with the cubic part here, the cube part here. So let's actually recall power law. Power law means that this cubic applies to every single exponent in this bracket. In other words, my base is still 2, my base is still x, my base is still y. However, the exponent is going to change. This 1 is going to triple, becomes a